Hello there. Welcome to my YouTube channel. Today I will take you through friction in mechanics of machines 1. Let's begin with this question. A body, resting on a rough horizontal plane required a pull of 180 newtons inclined at 30 degrees to the plane just to move it. It was found that a push of 220 newtons inclined at 30 degrees to the plane just moved the body. Determine the weight of the body and the coefficient of friction. Solution. Given. Theta is equal to 30 degrees. Let W equals weight of body in newtons. Rn equals normal reaction. Nu equals coefficient of friction. F equals force of friction. First of all, let us consider a pull of 180 newtons. The force of friction, F, acts towards left is shown. Now resolving the forces vertically. Rn equals W minus 90 newtons. From F equals mu Rn. 156 equals mu into W minus 90. Now let us consider a push of 220 newtons. The force of friction, F, acts towards right as shown in the figure. Resolving the forces horizontally. F equals 190.5 newtons. Now resolving the forces vertically. Rn equals W plus 110 newtons. From F equals mu Rn. 190.5 equals mu into W plus 110. From equations 1 and 2. W equals 1000 newtons. Nu equals 0.1714. Here is a second question. An effort of 1,500 newtons is required to just move a certain body up an inclined plane of angle 12 degrees, force acting parallel to the plane. If the angle of inclination is increased to 15 degrees, then the effort required is 1,720 newtons. Find the weight of the body and the coefficient of friction. Solution. Given. P1 equals 1,500 newtons. Alpha 1 equals 12 degrees. Alpha 2 equals 15 degrees. P2 equals 1,720 newtons. Let W equals weight of body in newtons. Nu equals coefficient of friction. Here is a diagrammatic representation. First of all, let us consider a body lying on a plane inclined at an angle of 12 degrees with the horizontal and subjected to an effort of 1500 newtons parallel to the plane as shown in figure above. Let Rn1 equals normal reaction, and F1 equals force of friction. We know that for the motion of the body up the inclined plane, the effort applied parallel to the plane, P1. 1500 equals W into sin 12 degrees plus mu cos 12 degrees. Now let us consider the body lying on a plane inclined at an angle of 15 degrees with the horizontal and subjected to an effort of 1720 newtons parallel to the plane as shown. Let Rn2 equals normal reaction. F2 equals force of friction. We know that for the motion of the body up the inclined plane, the effort applied parallel to the plane, P2. 1720 equals W, sin 15 degrees plus mu cos 15 degrees. Finding the coefficient of friction by dividing equation 1 and 2. Mu equals 0.131. Finding the weight of the body. W equals 4,464 newtons. Here is a third question. An electric motor-driven power screw moves a nut in a horizontal plane against a force of 75 kilonewtons at a speed of 300 mm per minute. The screw has a single square thread of 6 mm pitch on a major diameter of 40 mm. The coefficient of friction at the screw threads is 0.1. Estimate power of the motor. Solution. Given. W equals 75 times 10 to power 3 newtons. V equals 300 mm per minute. P equals 6 mm. D0 equals 40 mm. Nu equals 0.1. Finding the mean diameter of the screw. D equals 0.037 meters. Finding tan alpha, which equals 0.0516. Finding the force required at the circumference of the screw. P equals 11.43 times 10 to power 3 newtons. Finding the torque required to overcome friction. T equals 211.45 Newton meter. Finding the speed of the screw, which equals 50 rpm. Finding the angular speed. Omega equals 5.24 radians per second. Finding the power of the motor. Power equals 1108 watts. Don't forget to subscribe, like and comment. I am Engineer Mayday. When you need help, Mayday is the call. You have been an interactive learner. Thank you.